Well, our last video of the section will be pretty short. First thing we'll look at is a lemma called isometry composition. The composition of isometries is also an isometry. You could imagine taking a line segment and applying an isometry to it. It's going to move the line segment, but it's going to have exactly the same length. Well, if you apply that isometry again, it's going to move that segment, but it's again going to have the same length, and it doesn't matter how many times you apply it, how many times you compose them together, you will always have the same length line segment. So the composition of isometries is an isometry. Okay, finish up this video. We're not going to prove this theorem, but we'll maybe look at it as do an example. This says, if L, a line, is parallel to another line M, then the composition of two line reflections, the one around L and the one around M, preserves both distance and slope. Also, and this is what we'll do an example of, if you take the line N, any line N, apply the reflection SM around the line M, then you apply the reflection SL, the line around L. That line that you get out of that is going to be parallel to the original line N for every line N. Okay, so we're gonna just do one example. It says draw two parallel lines L and M. Well, I've already drawn them. I'm just labeling them L and M. See if I can get it focused. There we go. And then make N a transversal, a line that cuts through both of those parallel lines. All right, first thing we're going to do is draw N prime, which is the reflection of line N around the line M. So if I'm going to reflect this line N around M, I made M look like a vertical line. I need to do the best I can here. If I reflect it around, the mirror image is going to look something like this. Yeah, it's pretty close. It's not going to be exact, but something like that. Can you see how the mirror image, you just flip it around? If you flip in around this line, so you're just going from here, flipping it over there. So that's pretty good. That would be N prime, which happens to be S sub M of the original line N. N prime is the original line N after it's reflected around line M. Okay, and then next, we did this one. Next, I need to do this, which the other way of writing that is S sub L applied to S of M of N. Okay, so we already computed this. That's N prime. So now I need to take this line N prime and reflect it around the line L. Okay, so let's make L look like it's vertical. And I want to take the mirror image of the line N prime. So it's going to look something like that. Okay, so that's my N double prime, which I'll just make a note is SL N prime. Okay, so the claim was that this line, which we're calling N double prime, should be parallel to N. And yeah, N double prime and N look parallel Even my drawing actually isn't that bad at all. So this and this are parallel.